Okay, let us finally now learn how to solve an LPP. The method for solving an LPP is called the corner extreme method. The corner extreme method of solving an LPP. So what is this corner extreme method? Let's see this step by step. Step 1 says formulate an LPP. We have already formed the LPP. Let me show you. This was the LPP that we left in part 2, which we had already formed. The carpenter sum, the souvenir sum, sorry. A company produces two types of souvenir, A and B. We are continuing with that sum. This is what we had obtained after framing the LPP. Okay, so the step 1 is to formulate an LPP. We already have done it. Step 2 says express the constraints as linear equations and plot them on the graph paper. Okay, so let's go and solve this. Now I have to express this constraint. If you can see, this is the constraint that they are talking about here. I have to express this constraint as linear equations and I have to plot them in the graph paper. Okay, so let's start. So the method is very simple. If you remember, I have to do like this. 5x plus 8y is less than equals to 200. The step says you have to express these as equations, but it's okay if you just leave it in less than equals to form. Okay, it's okay, not a problem. So 5x plus 8y divided by 200 comes down, is less than equals to 1. Then 5x by 200 plus 8y by 200 is less than equals to 1, distributing the 200. So that gives me x by 40 plus 450 and 25. So y by 25 is less than equals to 1. Let me highlight this. I have it here. So this is 40 and 25. Okay, the x-intercept is 40 and 25. So let's start to plot. What is the x-intercept? 40 and 25. Okay, before we plot, we need to check the other one as well, because I don't know what numbers to mark on this axis. Okay, so we will check the second one as well. So second one is 10x plus 8y is less than equals to 240. I have it here. Then 10x plus 8y divided by 240 is less than equals to 1. 10x by 240 by distributing plus 8y by 240 is less than equals to 1. 0, 0 gets cancelled. That's 24 plus 30. Suppose that should be 30. So here I have it, the x and the y intercept. I'll put this in different color. So that's the purple one for the second equation. Okay, let's start to plot. Now how should I plot it? This is interesting now. How should I plot this on the graph paper? If I say each one of this is 5, this would be 5, 10, 15, 20, then 25, 30, 35. So on the x-axis, the scale is x-axis. The scale is 1 centimeter equals to 5 units. Okay, now let's do that. The same thing on the y-axis. This is 5. This is a 10. Okay, let me do that in different color. So that would be 5, 10, 15, 20, 25, 30 and 35. Okay, let's start to plot. The blue ones first here, so the blue highlighted ones, 40 and 25. On the x-axis, it has to be 40. So, okay, I need to make one more here. So that's 40 here, 40. So 40 with black, that's 40. And 25 on the y-axis, 25. So here is 25, if you can see, 25. Let's join this. So let me join this here. Let me join it. So it would be somewhat like this. Yeah, that's correct. And the second one, 24 and 30. 24 and 30. I have here 24 and 30. Let's plot that as well. So where would be 24? That's 20 here, that's 25. So 1 2 3 4, that's 24, if you can see here, 24. And 30 is quite simple, here is 30. So let me join that one as well. So I'll join this. Okay, here I have. So once I have joined both of these, now in your graph paper it would be more accurate. I have to okay, let me plot this line in a different color. Okay, let me make it in red, so that would be more easy to differentiate. So you can see, and yeah, that's more like it. Okay, now the red line and the black line I have here. So let's give direction to this line. First the black one. So the black one was the first one. So this is the first one. It is less than here. So less than would mean towards the origin here, towards the origin. This is the direction. Okay, so towards the origin, maybe not a little small, so towards the origin. And the red one is also less than, so it is also towards the origin. Okay, I have already plotted this. Finally I need to plot the non-negative restrictions as well. Here the two non-negative restrictions, x is less than equals to 0 and y is less than equals to 0. See, these are actually the, because if I write it as x equals to 0, y equals to 0, you know x equals to 0 means the y-axis here, this is the y-axis, and y equals to 0 means the x-axis here, the x-axis. So no need to plot these, just give direction. Less than, both are less than. So this line, let me put in black color, this would, okay, not black, green color, this line is less would mean x, or x is, sorry, not less, my mistake, it has to be more than equals to 0, sorry. So please neglect whatever I have said earlier. It has to be greater than equals to 0. So if it's x greater than equals to 0, it has to move upwards, isn't it? X greater than 0, let me plot it in green, upwards, because x greater than 0 means the sorry, x greater than 0 means the y-axis. So y-axis is greater towards the right, that's it. And y greater than 0 means the x-axis, it's greater towards your okay, up, like this. So now check this out. I have here 4 arrows of different color. Here you have the green arrow here, green arrow, if you can see. Here I have the black arrow here, black arrow, and here I have the red arrow, red, and finally I have this, I don't know what color is this, purple, pink, whatever. Okay, that arrow. So can you tell me now where is the common area for all these arrows? Okay, let me show you. So this purple arrow means all this side, can you say this side? So it sweeps all the area this side. Can you see that? Let me show you. Purple. Where is green? Green is here, green. Where is black? Black is this direction, if you see, this direction here. And finally, where is red? Red would also be this direction here, from here. Okay, so can you see where all the lines overlap? Where does all these 4 lines overlap? If you see exactly here, if you see, this is the green, this is the red also here, this is the purple, and finally this is the black also. So everything merges here inside this area only. Remember here, can you see this? This is called the visible region. This shaded area, this is called the visible region. Okay, so now you may say, why not this one? Why not this one? Here there is no red, there's no red here. Why not this one here? This one here, there is no black. Okay, and here there is no, you may say, both red and black. Okay, so it has to be the blue shaded region, that is called the visible region. Okay, so once I have the visible region, it's quite dirty, try to make sense here. Once I have the visible region, what I need to do is, now I need to plot the corner points of this region. I need to plot the corner points. So let me clear it out a little. So let me clear it out so a little clearer. Okay, that makes sense. Okay, so that was the feasible region here, shaded one. Okay, so what are the corner points? Let's say this point is A, this point is B, and this point is C, and this point is already O. You know it. Okay, so the corner points of this, can you see this corner point? This is the feasible region. The corner points of this region, there are 4 corner points. A, here A, let me highlight A, B, C, and D. These are the corner points of this feasible region. You just have to plot the corner points of the feasible region only. Okay, great. Let me rub all this. Okay, so I have plotted the corner points for the feasible region. So let's list it down in a table. So here I have the table. So the corner points here will be the corner points. Corner points are A, B, C, and O. And I need to find the value of Z here. What is the value of Z? So what is A? A is, by the way, let me write here. A is, A would be, value of Z here. Okay, the point. So A, what is A? A is here, I suppose that's 0, 25. That's on the y-axis. What is B? B is rather more interesting. You need to count it. B would be, my B is, this is 1, 2, 3, 4, 5, 6, 8, and that's 15 and 20. Okay, so that's more or less 8, 20. 8, 20. This is 8, 20. You can check it in your graph paper. What do you get? C is what is C? C is 25, 0 finally, and O here, O is 0, 0. Let's find out what will be the value of Z at this point. You just have to calculate it using the calculator. So just calculate the values of Z at all this point, and then we will see which one is the maximum, because this sum is to maximize. Okay, so the first one, when it is 0 and 25, my value would be 5 into 0 plus 6 into 25. Yeah, that's 5 into 0 into 6 into 25. Calculate it, it will give me 150 here. And the second one is 5 into 8 plus 20 into 25. That's not 20, 6 into 25 plus 6 into 2. Where am I putting this value? Here, Z, in Z. So that would give me, let me use a calculator, 5 into 8, and that's 40, plus 6 into 25. That gives me 190 here, 190. Okay, and 25 into 25 into 25, 5 into 25 plus 6 into 0. So that would clearly give me 125. And finally the 0 into 0, so everything here it would be 0. Okay, so I have here 4 values, all in purple: 150, 190, 125, and 0. Which one of this is maximum? 190. So here I have the answer, because this sum was to maximize is the objective function. So out of these 4 values, the maximum value is at B. The maximum value is at B. So the answer would be, therefore, the profit is a maximum when the company manufactures when the company manufactures manufactures how much? 8. I'll write it up here. 8 units of A and 20 units of B. So that is the answer for the linear programming problem. So the company would have maximum profit when they produce the souvenir, 8 souvenirs of type A. So 8 souvenirs of type A and 20 souvenirs of type B. So that is how we find the answer. By the way, finally this region is called the feasible region. feasible region. If you look at your formula, what is the feasible region, I have already discussed in your formula copy. So you just check out the formula that you have written in your formula copy. There you have the definition for the feasible region, and according to the definition it says the common region determined by all the constraints and the non-negative restriction of an LPP. So feasible region is that region which is the common region for all the lines. Okay, the common region swept by all the lines. Here we had 4 lines. How the 4 lines? The 2 lines we already drew, the black colored one here, the red colored one here, the y-axis and the x-axis. Okay, these 4 lines, wherever they merge or wherever they have a common area, that is here in this region, that is in okay, this purple region. Can you see that here? I've shaded it again here. So this is called the feasible region, and to find the answer of an LPP, you just need to list out the corner points A, B, C and O of the feasible region and find the value of Z in the corner points. So if the sum is to maximize the minimum of these 4 values, here you have the minimum of these 4 values, 1 value, 2 value, 3 value and 4. The 4 values would be the answer. The maximum of these 4 values, again the maximum of these 4 values here, 1, 2, 3 and 4, would be the maxima and the minimum would be the minima. This sum was to maximize, so I took the maximum answer 190. Okay, so had it been minimized, I would have taken 0. No, not 0. I would have taken 125 because 0 is a trivial answer. You can't have 0 units of type A and 0 units of type B. So that's how we solve an LPP. Okay, great.